This is a topic that I think a lot of students have problems with. Some of the students that I've tutored always have issues with balancing chemical equations. So hopefully this video will be helpful. So first thing we need to talk about is what is a chemical reaction. And all a chemical reaction is, it's a process that involves the rearrangement of atoms to form new substances as opposed to just having a physical change. So in this example here we have silver reacting with dihydrogen sulfide and forming different products. And as you can see, the atoms that make up um, this molecule here rearrange themselves to form a different product. Now, before we go on and talk about how to balance chemical reactions, it's very important to understand for those people that are beginning, balancing chemical reactions, you have to understand the difference between um, a subscript and a coefficient. So a subscript is denoted, for example, by this 2 here, this 2 here, and this 2 here. When you're balancing chemical equations, you don't touch those, okay? I have seen some students in the past make that mistake. So those things are never, ever, ever changing, okay? Dihydrogen sulfide, for example, is a stable molecule because you need 2 hydrogen atoms to balance out 1 sulfur atom. Okay, because if you do the analysis here, you'll find that sulfide has a -2 charge, okay, -2, and hydrogen has a +1 charge. Well, to make that stable, it's logically you need 2 hydrogens to make it a net 0, right? So the 2 plus will cancel out with the 2 minus, and that's why you need 2 hydrogens there. So this will never change. What you do change during balancing chemical equations are the coefficients. Okay, so that's what you have to make sure that you understand. Okay, so why do we have to balance chemical equations? Um, in a chemical reaction, you have to understand that matter is neither created nor destroyed. Okay, so in other words, the number and the type of atoms going into a reaction must be the same as the number and type of atoms coming out of the reaction. If an equation obeys the law of conservation, it is balanced. So the reason why is because matter cannot be created or destroyed. Matter is only changed from one form into another. Okay, and I'm not talking about phase changes, perhaps. I'm talking about chemical reactions where you're having a new substance being formed. However, the atoms are essentially the same. Okay, they're just rearranged differently. Okay, so that's the reason why, and the reason is because matter cannot be created or destroyed. Mass is conserved. So what do you do when you balance chemical equations? What you do when you're balancing chemical equations is you have to make the number of atoms for each type that you see on the reactant side equal to what you see on the product side. Okay, and I put down some steps here, and I have some tips on the next slide. And I just want to say that balancing chemical equations is just like anything else. You get really good at it with more and more practice. So I encourage you to practice and practice and practice. And you can find a lot of really good resources online. I came across one website that had 250 chemical equations that you can balance. Some are going to be easier than others. But I think as you go on and practice, you're going to find that it's more like trying to solve a puzzle than anything else. And the steps that I have here for you, it will eventually become something so implicit that you won't realize that you're following any steps. So you just kind of have your own set of rules that you're going to follow over time, but because you've done it so many times, it's just natural. Okay, so what I'm trying to say is these steps are more like guidelines. Okay, you don't have to necessarily follow them all the time. Okay, but when you're starting out, you can kind of use them to kind of help you out. So the first step is balance the metals. Second, balance the nonmetals except hydrogen and oxygen. Balance hydrogen and oxygen. And the fourth one is actually very important. Be versatile and exercise your analytical thinking skills. And because there's more than one approach to doing this. And in fact, in the next slide, right, if you notice, the next slide, the very first step that I tell you to do, or the very first step that I give you, is to take the metals and balance them last. Well, that kind of goes against what I'm saying here. The point is that you could do it either way, right? You can follow this, and if this works for you and you're getting it, then great, follow it, awesome. If not, then you might want to follow the tips that I have here, okay? So right there, it kind of contradicts what I had in that first slide, but that's okay. Okay, you have to understand that there's more than one way to do this. Okay, so another tip is that you can leave diatomic molecules last. And what's a diatomic molecule? It's something that's made up of two atoms. So hydrogen, for example, is a great example of a diatomic molecule because that's H2. Number two, I really like this one. This is a great tip. Polyatomic ions should be treated as just one entity. Okay, so if you have something like, I'll try using my little pen here. If you have something like, I hope this works, you have like a phosphate, okay? And you could look at it as, okay, I've got one phosphorus, I got 4 oxygens. Or you could look at it as, I have one phosphate. If you choose to look at it as one phosphate, I promise you, your balancing is going to be a lot easier. Okay, so this is a tip that I really, really like. Another tip that I really like, and interestingly, some teachers don't like this, is use fractions if you need to. Fractions are okay, but at the end, when you finish, just make sure you multiply to get rid of the fractions. Again, we talked about not ever changing the subscripts. Again, another mistake that people can make when you're first starting out is the coefficients always go in front of the molecule. They never go in between the atoms that make up the molecule. Okay, they always go in front. Use your lowest common multiple when you're multiplying. And this is another tip that I really like. And I think it's really good for students to just understand the chemistry that's happening. If water is ever a product in the equations that you're working with, rewrite water as HOH. You're not changing anything. But what this allows you to do is it allows you to examine and look and find out where that OH group, that hydroxyl group, is going in your chemical reaction. And that allows you to understand the chemistry a little bit better, and it enables you to balance easier, because instead of trying to balance 2 hydrogens and an oxygen, which can be tough to do sometimes, you're balancing out a hydroxyl group. Okay, you're balancing out the OH. Okay, in other words, by doing this, you're making tip number 2 something that you can use. So that's really good too. And simplify to get lowest whole number ratios, which is actually a mandatory. That's something that you need to do. Okay, so of all the tips that I've given you, I highlighted 2, 3, 7, and 8 as being really, really good ones to use. Okay, so we talked about coefficients and subscripts, so I'm just going to skip this. Okay, so here's the first chemical reaction we're going to balance. That's sodium bromide. That's calcium fluoride. Reacts to give you sodium fluoride plus calcium bromide. Okay, so you have to separate your reactants from your products, and just set yourself up a table here, to kind of help you with the accounting. So just go ahead and account for all your atoms. So we have sodium here, we got bromine, and we've got calcium, and we've got fluorine. So that's my left side, my reactants. Of course, every single atom will have to show up here as well on the the product side. Okay, and notice that I'm not writing it in the order that I see it. I'm writing it in the order that I chose to write for the reactants. Okay, the order really doesn't matter. So we go ahead and we take into account, we got one sodium here, one bromide, calcium, and two fluorides. So we're going to go ahead and put a 2 here. Okay, we got one sodium, two bromines. Okay, so we got to put a 2 here, one calcium, and one fluoride. Okay, all right. So now we're just going to go ahead and kind of play around with things here. Okay, so we notice that we've got two bromines. What throws us off here is the bromines and the fluorines. Okay, so but this one actually kind of works out. So you could actually choose. What I'm going to do is I'm going to go ahead and I'm going to choose the bromines to work with. Okay, that's just an arbitrary choice. So I notice I have two bromines here, and I've got a bromine stuck to a sodium here. So I'm going to go ahead and I'm going to add a 2 here to kind of balance out my bromines. So my bromines are balanced. But what happens a lot of times is because you can only alter coefficients, when you balance one atom, you are going to affect a number of different atoms. That happens a lot. That's why balancing chemical equations can be challenging. So here, what we have to do is we have to look at our sodiums that are kind of out of whack, and it works out quite nicely because all we need to do is just put a 2 here, okay, and we notice that our sodiums now balance, okay, and everything else appears to balance. So now we just take one last check. We got 2 sodiums here, 2 sodiums, they balance. We got 2 bromines and 2 bromines here, they balance. Okay, there's a 2 for the bromine. We got 1 calcium here and 1 calcium there. We've got 2 fluorines, and we've got this coefficient making 2 fluorines. So we have a balanced chemical equation. This other example I have for you is what I would consider to be, for a beginner, a challenging chemical equation to balance. So here is, pardon me, here is the reaction. So we've got sodium is going to react with sodium nitrate. Okay. And that's going to give you sodium oxide plus nitrogen gas. Okay. Now, what makes this hard chemical reaction or tricky one to balance is the fact that you have sodium metal by itself reacting with a molecule that has sodium within it. So that's going to make things kind of tricky to balance. Okay, so again, we're just going to go ahead and set up our list. Okay, and another thing with that one tip, the nitrate is polyatomic, but we can't apply the rule here because we don't have nitrate on the other side. Things rearrange themselves. So it's going to be a bit of a tricky one to balance. So we got nitrogen and we got oxygen. Okay, we've got sodium, we've got nitrogen, and we've got oxygen. Okay, one sodium, actually got 2 sodium, so I'm going to put a 2 over here. We've got 1 nitrogen and 3 oxygens. Okay, we've got 2 sodiums, 2 nitrogens, and we got 1 oxygen. Okay, so this is going to be a little tricky to balance, but let's try and see what we can do here. So I'm going to go ahead, and because I have sodium here and sodium there, I know that if I choose to work with the sodiums first, that I'm going to be affecting the other elements as well. So I'm going to go ahead and I'm going to try balancing out my oxygens. Okay, and the reason why I chose oxygens is because I want to leave nitrogen at the end because it's diatomic. So that's my personal thing that I like to do. So I'm going to go ahead and try and see how this works. So I have one oxygen here and 3 oxygens here. So my question to me is like, okay, can I just simply put a 3 here and balance it out? Yeah, I can do that. So let's try. I'm going to put a 3 here. And now we're going to see that the oxygen's balanced. We got 3 here and we got 3 here. Okay? But what happens is we have 6 sodiums now. Okay? So we're going to cross this out and we're going to put a 6 here. And we can see that it's not balanced, right? So we run into some problems there. Okay, so how are we going to balance out these sodiums? How are we going to balance out this equation here? So 3 oxygens, 3 oxygens. Sodiums, I really want to just kind of leave that for last. So if I take 2 nitrogens, right, and notice I got 2 nitrogens here. If I go ahead and I add a 2 here, okay, right, I notice that my nitrogen's balanced. Now, I kind of contradicted myself here because I just said that I wanted to leave this for last, right? But in this chemical equation, I noticed that while I was doing it, and this is where you have to exercise your analytical critical thinking skills, I kind of thought to myself, you know what, I'm going to run into some problems with my sodiums because I got sodium here, I got sodium here, I got sodium here. And it's just because the way this is set up. So I decided to go ahead and balance my nitrogens first. Okay, and I can kind of see that I'm going to have to alter some other numbers here. So what happens is I added two more sodiums here. So my total number of sodiums on this side now becomes 2 plus 1 is 3. So I'm going to cancel this out. And once again, my sodiums are unbalanced. Okay, so question now becomes is, oh, and I noticed something else actually. You know, our oxygens are unbalanced. So we have 6 oxygens now on this side. And we have 3 oxygens there. So 3 in total. So now I can kind of see that I have to alter the number of oxygens on this side of the equation to balance out with this one. So I'm going to have to take out this 3 and I'm going to have to put a 6 there. Okay, so that will balance out my oxygens. All right, but again, what happens? Well, my sodiums are unbalanced. 6 as a coefficient times a subscript of 2 gives 12 sodiums, right? So now I'm really balanced out here. I'm at 12, 2, 3 here. So what's nice about leaving the metals for last and something that's on its own for last is you can always change it easily to balance it out. So we have 12 sodiums here. What plus 2 is going to give me a total of 12 sodiums? So I can go ahead and stick a 10 here, and I should have a balanced chemical equation. So let's do our counting again. So we got, oh, sorry, that's not 10, that's 12. Okay. So we have 12 sodiums, 12 sodiums. We have 2 nitrogens and 2 nitrogens. Okay, that hasn't changed. 6 oxygens and 6 oxygens. This is a balanced chemical equation. So this example really shows you how you kind of just have to solve it like a problem sometimes. Okay, and it just takes a lot of, you know, guessing and testing and just figuring it out and struggling a little bit, and you will eventually get the balanced chemical equation with practice. That's why I chose to do that one, to highlight critical thinking and analytical thinking that you're going to have to exercise while you're doing this. The last one is one I wanted to do and show you to kind of highlight the use of another tip. So we got aluminum plus hydrochloric acid gives you aluminum chloride plus you get some bubble forming because of hydrogen gas. Okay, so let's account this right here. We have aluminum, we've got hydrogen, we've got chlorine, aluminum, hydrogen, and chlorine. We've got one of each here on the side, and on the other side we've got 3 chlorines, and we've got 2 hydrogens. Okay, so how are we going to balance this out? All right, so I'm going to start. When it comes to this kind of equation, I like to start with the most complicated one. So there we go. We've got aluminum there, 1 to 1. Don't want to change that. I'm going to go ahead and I'm going to balance out my chlorine. So I'm going to stick a 3 here. Balance out my chlorines. So I got 3 to 3. But that does affect my hydrogens now, right? Because I got 3 hydrogens and I have 2 hydrogens. Now, this is where the use of fractions can really help. Okay, so how am I going to get this to balance out so that I can get 3 here? Well, if I have hydrogen, I'm just going to write down hydrogen here, right? And if I want to get a total of 3, then my coefficient, right, it would make sense that it would have to be 3 over 2. Okay? Now, why did I do that? The reason why I did that is because if I take 3 over 2 and I times by 2, let's see what I get. I get 3 over 2 and I multiply it by 2. I get 6 over 2, which is equal to 3. Okay? So that way, now, if I do that in my chemical equation here, 3 over 2, right, this becomes 3. Okay? See how I did that? Okay, so that's how you use fractions to help balance out chemical equations. And right now, this is actually a balanced chemical reaction. Okay. However, tip number 8 that I gave you earlier, you have to understand that you have to get rid of fractions. Okay. And to get rid of fractions in a chemical equation is that you have to multiply whatever factor you're going to multiply by and apply it to the whole chemical equation. Okay, you cannot just multiply and apply the factor to the 3 over 2 to get rid of the fraction, because it's going to apply to the whole thing. So I have to think to myself, I want to get rid of this 2. Okay, so that means I'm going to have to take this whole chemical reaction and multiply it by exactly by 2, because when you multiply it by 2, right, just as this example is showing us, right, this is like 2 over 1, right? So the fractions will cancel out, and so that's what we're doing when we're multiplying by 2. So I'm going to take a bracket here, and I'm going to rewrite the whole equation afterwards to make it clear. And I'm going to take it, I'm going to multiply the whole equation by 2. Okay, so when I do that, my balanced chemical equation will be 2 aluminum plus 6 hydrochloric acid, or hydrogen chloride, and that's going to be 2 AlCl3 plus 3 and there you go. Okay, so that should be the balanced chemical reaction. So we can check one last time. I've got 2 aluminums and 2 aluminums. I've got 6 hydrogens. 3 times 2, I got 6 hydrogens. I've got 6 chlorines, and I've got 3 times 2, 6 chlorines. So fractions can be very useful when balancing chemical equations. I hope that helps.